Yeah, how's the sound?
Well, nobody can talk back to us, so.
Yeah.
Just chat. Maybe in the
So
chat
send us a
window.
chat message if you can't hear us. So if you're wondering if there's audio, there is. You're hearing it now.
All right, should we blast off?
Sure.
Okay, folks, we'll get started. So thanks for joining us today for another webinar coming from Apogee World Headquarters here in Palo Alto, California, sunny Palo Alto, California. We're going to talk about scaling today. We've talked about this once before, and we're going to go at it from a bit of a different angle today. And we're going to talk about feeding your speeds. So I'm joined today by, well, I should say, I'm Brian Pagano, and I'm the Chief Solutions Architect here at Apogee, and I'm joined by my esteemed colleague, Greg Braille.
Hi there, I'm Greg. Good to meet you guys.
As always, I'd like to remind everybody that there's the after party at the Google group. This is a vendor-neutral group, which has, I think, become the single hottest focal point for API discussion on the internet. Absolutely fantastic discussions every day on there. So I encourage everyone to join us and send any questions there afterwards. As always, we've got videos of all these webinars available up on YouTube, so feel free to go and check those out.
Yeah, and as always, we'll put these slides up there as well as the video, so you don't need to furiously take notes or anything like that. And someone says no audio. That's interesting, because I think Baruta can hear us. So I think we're going to keep going and let her work on the issues if there's any problems. Okay, so we're going to go on, and if there's a problem and we need to restart, I will let Baruta direct us. Thank you.
Okay. Additionally, we did, at audience request, we set up an IRC channel. So that's also at hash API Craft on Freenode, so feel free to join us over there also. All right, so we've talked about scale once before, right? And we started at a very high level, and we came downward. Today, we'd like to talk about scale from a different angle. And we'd like to specifically talk about when we say scale, what do we mean, and what does it mean to scale an API? So Greg, I think the sanest way to approach this conversation is basically to break it up into a couple of dimensions, right?
Yeah, exactly. So if we talk about scale in general, it means a lot of things to a lot of people, and the word scale is pretty ambiguous. So we are going to narrow this down a lot. We're going to talk about specific technical stuff today. We're going to talk about application servers and databases and networks and all that. And by the way, I apologize for the WebEx issues. Somehow WebEx is behaving differently today than it has for other Apogee webinars we've done, and we're hearing the badoop as well over here. And we don't know why, and we're working on it. So while we're talking, we're working on figuring out what WebEx is doing today. So we apologize for the badooping. We wish we could stop it. So we're actually going to get in touch with WebEx and work on that. I have not had a problem in any webinar I've done with this stuff, so I'm not sure why it's different today. So please be patient. So talking about scale. Scale is a whole lot of things to a whole lot of people. We're going to talk about specific technical stuff today, but I just wanted to set the stage, because I think there's a lot of aspects to scale that we can talk about as we do more of these webinars. So for instance, scaling to a lot of developers. How do you support developers in a scalable way and manage your developer program if you have 1,000 or 10,000 or 100,000 developers? How do you manage apps? How do you get analytics on all those apps? How do you give the right access to all those apps if you're lucky enough to have an API that has 1,000 or 10,000 apps built? If you're lucky enough to have an API that has apps built that has millions of end users, that has certain dimensions on scale. For instance, the way you do authentication. And then versions. Versions are totally an aspect of scale too. Supporting many API versions in parallel is an aspect of scale that's probably more complicated than a lot of these, because you can't just throw hardware at it. You have to throw people and resources and brain power at it. So scaling to a lot of API versions and client device versions is another dimension. But for now, for today, we're going to focus really on scaling to handle many, many API calls. Because all of these things here, the more developers you have, the more apps they build, the more end users they have, it all results in API traffic. So we're going to focus today on things you have to do as your API grows to handle large numbers of API calls.
Okay, so that's the dimension we're zeroing in on today.
Yes.
Simply API, the volume of API calls coming
Yes.
through. All right, excellent.
So, this is my little dig. I'm of course a technology guy, but I've done many roles in my career, and there's always a meeting at some point where someone says, we don't want to talk about speeds and feeds.
Right.
And in many meetings, that is exactly the right attitude. You want to get your business strategy worked out. You want to know why you're doing something. You want to understand how it affects the business. But today we're going to talk about feeds and speeds. So
today is that meeting.
Today is the feed and speed meeting. So
Okay.
anyone who doesn't want to hear about feeds and speeds, please, be patient with us while we talk about them. So why do APIs need to scale? Well, because APIs are for end users, and there are lots of end users. So if you're building an API for mobile apps, or if you're building video streaming or something like that, obviously you expect it. We also talk to customers who come more from the enterprise world, where they may have an internal system designed for 100 users, and they'll say, let's make this into an API.
Right.
And now they might have an audience of 1 million end users, and that's a very different kind of thing.
Right. You mean you can't just expose the exact same system out to 1 million users and everything will be fine?
Yes, you can. A
Sure.
couple of servers are running.
Well, you can expose it.
You can expose it, right? So if we have thousands of app developers,
Uh-huh.
thousands of apps, millions of end users. You've got lots of database records. You got lots of access tokens. You got lots of credentials, and you result in lots of API calls. So, for instance, if you have 1 million end users, everyone makes 1,000 API calls a day. That's 1 billion API calls a day.
Okay.
That's 11,000 per second on average, assuming I got my math right. And I checked some of the math right before this presentation, so I think I did. So that's a lot. And we're going to talk about how that's different from getting 10 API calls a second, which is also a lot in many instances. And talk about things like the technology infrastructure you need, and maybe some things about your API design as well.
Okay,
So
excellent.
let's get into that.
Excellent.
So
Okay.
we're going to talk about throughput.
Right, just the raw number of calls coming through your API platform.
Right. So I'm gonna spend 2 minutes in definition land, because I talk about this stuff all day long. So we just throw around terms, and you do too, like throughput and latency and concurrency, and
Right.
it's just everyone knows what we're talking about.
Right.
In case you don't, throughput means the number of things you do in a period of time. So typically it's expressed in transactions per second, or API calls per second, or per day, or per hour, or per minute. We're going to use per second because we want to talk about fast APIs.
Okay.
Other tremendously important to mention here is latency. Latency makes you late, right? That's how long it takes to do something. So you can set up an API platform that handles 10,000 API calls a second, but if the latency is 20 seconds, no one is going to use your API.
Right.
Because they're going to open up the app on their phone, and they're going to, well, what the hell is wrong with this thing, right? So,
right, exactly.
So the two go together,
Right.
but we're pretty much going to talk today about how to have a lot of throughput, because that's usually what happens as you get a lot of people using your API. And we're going to assume that you're trying to return some sort of reasonable latency. You're not just trying to handle a ridiculous throughput number. And there are ways that computer systems behave as you increase concurrency and as you increase throughput, and as resources get saturated. At some point the throughput levels off, but we're not going to really get into that whole thing today. We're going to talk about really increasing throughput, and we're going to assume that you want to maintain a reasonable latency while you do this.
Okay.
We'll also talk about a few things specifically designed to reduce latency in API calls. Because the two, they're separate in their two dimensions, but they really go together. Throughput with unreasonable latency doesn't really mean anything to anybody.
And certainly wouldn't be a permanent situation. You would start to lose your traffic anyway with high latency.
Exactly.
Okay, but I think this is a good way to keep us relatively sane by kind of separating these, by really focusing this discussion on just sheer throughput.
Right.
How many transactions per second are going through your API,
right,
with an understanding that latency needs to be kept under control.
You got it.
Okay.
So, what limits these things? Well, there are a lot of things out there that limit these things, right? And I'm going to talk about the whole stack. Your disk, your network, your CPU, your memory to a certain degree, the performance of the database, the performance of the app server, the API proxy if you've got one, the load balancer, the firewall, the cache. All of these things play into how many API calls your API platform can handle. And each one of them can be the bottleneck. And they can all be bottlenecks at different times and for different reasons.
I got it. So these are the things we should keep in mind, but that at different throughput levels, different pieces of these are going to break.
You got it.
Okay.
You read the slides. No, I'm kidding.
I did. I looked ahead just so I'd be able to follow along with you.
So for instance, and we're not going to get into super detail about this stuff. That's probably for the database implementation webinar. But on the disk, stuff like the seek time, the rotational speed, and the transfer speed is going to limit your disk performance. Your disk performance is going to limit your database performance, which is going to limit your app server performance. Your clock speed and the number of cores is going to affect your CPU performance. But it's also going to depend on what kind of app server you're using. Some of them do great with multiple cores, some of them don't. The amount of RAM you have affects your caching. The way your app is designed and the way your proxy is designed and the way your load balancer is configured affects the throughput. Again, any of these things can be a bottleneck. And at some point in the life cycle of your API, you may find yourself in a situation where you're just running benchmarks saying, okay, looks like the bottleneck is the load balancer. It's at 100% of the CPU. Let's try getting a bigger load balancer. Oh, now we got more throughput, but now the app server is running at 100% of the CPU.
Right.
Or the disks are busy on the database. And that's kind of the art of performance tuning, is knowing where to look and what to fix and not just guessing.
Right. Just always finding that next weakest link in the chain.
Yeah. So I don't have a lot of slides on that, but I think at some point it would be fun to talk about some strategies for how to actually do this, right? How do you actually find a performance bottleneck? Because I frequently get called into situations where sometimes we've done a great job, and sometimes us or a customer or some third party has said, your API is slow. Well, how do you know? Well, I ran curl and it took a long time. Okay. How many APIs did you call? One.
Right.
Okay, well, with one, that's not no information, but I prefer if you made, a million,
Right.
reach more of a conclusion from that, right? So.
Okay, so you're saying that, armed with the information from this webinar,
Yes.
there should be probably a follow-up discussion on actual performance tuning.
Yeah, and performance testing. Maybe
Yeah.
we can talk more about ways to performance test an API. That could be a lot of fun.
Okay, perfect.
Great. So what we're going to do today, now that we've done introductory stuff for a long time, is we're going to talk about what happens as your API infrastructure scales to handle different amounts of API calls. And we're just going to talk about each level. What happens at 1 TPS? What happens at 1,000 TPS? This may not be news to all of you. Some of it may be. This is going to be a little subjective and based on our own experience. Some actual benchmarks we've done, some, this is what we've seen out in the real world, both in our own experience and by talking to others at Apogee. And hopefully it'll be a little bit of fun.
So that was the your mileage may vary clause. But
your mileage will always vary.
Right.
The thing about performance is that every single thing affects every other thing. So people will say, what's the fastest database? And the answer is always, for what?
Right, exactly.
Right?
Exactly.
What's the fastest app server? Why are you asking? But we can make some generalities, and we're going to try and do that today.
Great. And I'll just comment on this slide, real value add here, that I was a little disappointed when I looked over the deck and saw there were no Star Wars references. But I got to tell you, this kind of looks like it, doesn't it?
A long time ago, in a
Well,
galaxy far, far away, there was a slow API.
It's the Death Star API, or it's the mathematical aspect that we never saw. This is probably in the special edition they're going to release later this year.
There you go.
So obviously, to scale your APIs, you need a handful of dirt. No, or have I misunderstood this?
It's a great picture.
Yeah. So I think the metaphor will become clear as we go on. But I think we're saying we're starting small. Starting with something that's just sprouting. So your API program, maybe you've got a brand new product, a brand new feature set, or you're just exposing your API program, or your API and getting your API program off the ground. It's just sprouting.
Yeah.
So obviously your traffic is not going to be at Facebook, Google, Amazon levels at that point, right? So walk us through what the world looks like at one transaction per second.
So the first thing is that for some people, one transaction a second is actually not too bad. That means if you maintain one transaction per second on average all day long, and I know that there are peaks and valleys in the worlds of APIs, there are huge peaks and valleys, but still, I'll just do some math based on averages. On average, if your API handled one transaction a second, that's 86,000 API calls a day.
Okay.
There are a lot of websites out there that would love to get 86,000
Sure.
visitors a day or 86,000 hits a day.
Sure.
So one transaction a second is not necessarily all that shabby.
Right.
Nonetheless, from the perspective of what we're talking about, it's not a huge challenge to handle one transaction a second most of the time. Anything from Google App Engine to a small or a medium-sized EC2 instance to a lot of different platforms, anything from PHP to CGI, can handle a transaction a second, right?
Okay, so you're saying the kind of technology stack that just about anybody would have in place to have their API exposed probably can handle this kind of load.
Probably. Now, there are definitely ways to screw it up.
Okay.
Like if you're using a SQL database, and in order to process that one transaction a second, you have to query 10,000 rows.
Okay.
Or do 6 joins or something like that. Your database may struggle to handle one transaction a second. Or if you're doing some heavy computation, I mean, if you're doing some sort of heavy-duty financial analysis, and you're not in a low latency trading kind of world, and if you are, by the way, I'm sorry, we're not going to help you on this call, but that's another thing. Then you're probably you may not be able to handle one transaction a second. But so this is an opportunity to talk about some basic best practices, but to say, first of all, one transaction a second is not necessarily all that shabby.
Right.
And next, however,
Okay.
unless what you're doing is tremendously complicated, you're probably going to be okay.
Okay. So if someone has, so they've gotten most of the way there. They've got an API.
Right.
They've got something out there. They're actually getting 1 TPS.
Yeah.
So what do they do?
Right. So I'm going to assume your API isn't doing anything really weird like video transcoding, but that you're talking to a database and you're letting people insert and delete records and query stuff.
Okay.
Chances are, if you're on this call and you've built web apps, you probably have a database. So that's probably going to be the first place you're going to have to look for any kind of issues, and that's going to be the case for a while. And we'll talk a lot about databases today, right? Traditional relational databases do a lot of things very well. They don't really scale horizontally all that well without a bunch of work. So you're probably going to end up doing things like tuning your database installation. Can you monitor your queries to find out which queries are slow? Can you make sure your indexes are properly created? Basic relational database stuff that a good DBA or a good administrator will know how to use.
Okay.
But the real important thing is that even if you're starting small and you're starting at 1 transaction a second or less, if you can put some sort of testing and regression testing regime in place now, that's going to help you enormously later.
Okay.
Do you have a performance regression test you can run on your API? Can you push your API maybe to a lot more than 1 transaction a second so you're confident you can handle 1 transaction a second all day?
Okay.
Have you run the test long enough? For instance, let's say that every time you get a transaction, you're putting a row in a database, or you're putting 10 rows in a database. And it works great for 15 minutes. What if you run it for a whole day? Now you've got 86,000 records in your database.
Right.
A couple of days later, you have a couple million rows in your database.
Right.
Maybe you didn't plan for that.
Right.
So having that testing regime and establishing that early on is almost one of the most important messages here.
Okay.
I've worked in environments in software development where we actually had nightly performance tests. And if you checked in some code to the system and you broke the nightly performance tests, someone assigned you a defect. And you had to go back and say, why did the code you checked in yesterday make the performance test run 5% slower? Now, 5% isn't much, but if you think about the fact that this is all compounded, right? If you make something 10% slower and you do that 7 times,
right,
you've made it half. You made it it works better the other way around. If you make something 10% faster,
right,
you only have to do it 6 more times
right,
to make it run twice as fast.
Okay.
So.
Okay, so
Anyway.
the real lesson at the 1 transaction per second level seems to be watch the database,
Test, monitor your
and
database.
test.
Absolutely.
Okay, got it. All right, and then we're starting to grow the platform. I feel like there should be a Crouching Tiger story here, but anyway, so the handful of dirt has grown into bamboo.
How many geek movies can we refer to in one conference
Oh, I
call?
think in some of these webinars, I think the number is pretty high.
Okay.
So, all right. So now we've gone from 1 transaction per second. Now we're up to 10 transactions per second. So this is a pretty decent amount of traffic.
Yeah. Now you've got almost 1 million API calls a day. So you've got 25 million API calls a month. If those API calls represent real business for your company, again, you're probably doing okay. You know, we have customers for which this would be a lot. We have customers for which this would be a laughably small amount of traffic, right?
Right.
Still, a lot of infrastructure, most infrastructure out there can handle 10 transactions a second. Your database, if you got it for 1, you could probably tune your database to handle 10 transactions a second, right? If you have your application written for 1, it's probably not a big thing to handle 10.
Right.
However, it's probably time, if you're reaching this traffic level, to start thinking about your app server. How have you designed your app? Does every one of these transactions go to the database 8 times? Does it try writing to a file? Does it open a lot of network connections to other services? You know, have you coded it well depending on the environment you're running in? At this level, you probably don't need to worry about which app server you're using, because they should all be able to handle this. But still, the way you've built your app may have a big effect. You know.
Okay.
I mean, if you've built a PHP app and it uses an excessive number of modules, I'm not a PHP expert, but I'm sure there are ways to build a PHP app that will struggle at this level of performance, as there are ways to build it that'll handle it fine.
Okay.
It's hard to screw this up in Java, but you know, every API call opens 5 network connections to slow servers or makes 10 database queries.
Right. Right.
It may not be the best design app.
Okay.
Hopefully your testing will zero you in. Hey, here's the part of the API that's really slow. So that's where we need to focus.
Okay. So, but this is the next weakest link in the chain here. So it's likely to be the application server level that's going to start.
That's where you're going to have to start looking. And as you grow, now you're going to have to start thinking about other stuff.
Okay. And it's really about, again, much like at the 1 transaction per second level, it's about watching the number of database calls. Am I getting too chatty with the database, or are my queries too big?
Right.
And like you said, this is where call-outs to external services and things can start to be your weak link.
Yes.
Okay, so that's what's likely to break down at this level.
Exactly.
Okay.
But again, a lot of platforms can handle this. You don't need to go all, Facebook-y yet.
Right. No, I get what you're saying. So in both of these first 2 steps, probably whatever technology stack you're using can handle it if you're doing things.
If you're doing it well and tuning it right.
Yeah, got it.
And maybe you throw a little bit of hardware at it.
Okay. Well, that's a reassuring picture.
Forest.
Yeah, that is a pretty forest. That looks like the sun is shining through. Your API is absolutely thriving there, and I don't have any movie reference. I'm sure there's one somewhere out there.
The Shining or something. So no, it's not snowing. So now we've got 100 transactions a second. As I said, now we're getting somewhere. You got almost 259 million API calls a month if you sustain that throughput on average. Depending on your database, you can get a relational database to handle 100 queries a second without excessive struggling. You can get an app server to handle 100 transactions a second, but now is when you start to think about your hosting options and your app server options and your database options, especially if you think that you're going to keep growing. So, for instance, something pointed out to me by a colleague, this is where if your app was running on Google App Engine, you were doing great, but now you're starting to have to pay Google.
Okay.
Google is, once you start paying Google, I think Google App Engine is a great platform. Once you start paying them, you could be running on EC2 or Heroku or Engine Yard and paying them the same amount, right? So, that's when, you're no longer in the free web app territory.
Sure.
You're actually starting to spend some money to host this.
Sure. But at almost 9 million calls a day.
Yeah, I mean, at 9 million calls a day, unless your API is tremendously inefficient and they aren't doing anything, and we'll get to that. Hopefully you're making some money on this.
I would hope somehow or
at least
you're
you're getting famous or something.
Somehow or other, if you're getting 9 million calls a day, it should be worth it to you to pay a little money.
Right. So we can kind of tune this. But at this point, you start to have to really start working on your database. If it's a relational database, it probably needs fast storage. Like if you're running an EC2, are you using the Elastic Block Store? Can you use the Instance Store? Can you use their RDS service? Well, the Elastic Block Store doesn't handle huge amounts of IOPS per second, so now it depends what your database is doing. Your database is going to need as much memory as you can give it if it's a relational database. You're still going to be optimizing queries. The other thing here is that now you have to start thinking about your choice of app server technology. Because, I mean, I know that people are going to tell me that, of course, my Ruby on Rails app can handle 100 transactions per second. Or, of course, my PHP app can handle 100 transactions a second. But you might have to scale that thing horizontally more than you would if we were using a more efficient platform. Okay. That becomes more critical as we get bigger, but we're reaching the point where, a lot of these, web app server technologies, especially the ones that spawn a whole process for every API call, or app servers that can only take advantage of one CPU core, there are some out there, start to become more of a liability.
Okay. Right. So this seems to be the level where it starts to get a little more serious now.
Yeah. And even if you're using an app server that can easily handle 100 transactions a second, have you configured the thread pools right? Did you build your app right? How are you doing SSL termination? Can you handle HTTP keep alive? Stuff like this starts to make a big difference in your performance.
Okay, yeah, little things you could get away with at lower traffic levels are going to really show the cracks right now. Yeah.
From an API perspective, if you chose to do XML digital signature processing and encrypt every API call with RSA public key, which I don't see very often, but people do try it, you need a lot of CPU to handle 100 transactions a second. If you're using OAuth and SSL, no problem, right?
Okay.
So
okay, excellent. But still, congratulations to anybody who's made it to that level of
seriously,
because
I know,
that is really great. And now the moon of Endor. Now we're on the.
I knew you were going to get to Endor at some point.
Well, it's a little redder than I remember Endor being, but I think you might see one of the speeder bugs.
And I think we're actually done with trees after this, if I look through this upcoming slides.
This is as big as the trees get, huh? This is. Oh no, but scale goes up here. So now we're talking about 1,000 transactions per second.
Right. So here's where we talk about specific technologies. Because, for instance, for something like a caching server like Memcache, or a Java app server that's not actually talking to a database a lot, or a load balancer, a firewall. I had another example that now has escaped me. Those kinds of technologies, 1,000 transactions a second is nothing.
Right.
An Apache web server serving up static files on a gigabit network can do that tens of thousands of times a second, right?
Okay.
No problem. On the other hand, a relational database is going to really struggle to do 10,000 writes a second.
Yes.
It may even struggle to do 1,000 reads a second.
Yeah.
A PHP, a CGI, a Ruby on Rails kind of server. I'm sure someone's got one out there that handles 1,000 transactions a second. I haven't seen that myself.
Okay.
I have seen, Jetty and Tomcat not even break a sweat. So this is where now we start having to ask questions like, what's the mix between reads and writes?
Okay.
And the reason why, and let's get to the next thing, is because, and this, again, obvious to all of you guys, reads can be cached. And this is where you have to start to really seriously start looking into caching.
Right, and I think we've seen that with our bigger customers that that's really the secret sauce on these really high volume, massive brand APIs. The more they can cache, the easier it's going to be on performance.
Right. Even Twitter, which is actually not cacheable at all, is actually built on giant tiers of caching, or at least was last time I saw a presentation about it, because at some point it's very difficult to write. And this is where we can really geek out on databases for a second. A traditional database, one of its design centers is to offer transactional consistency, and that means, for our friends in the financial community, if you happen to commit a transaction that said, please put some money in my account, and I lose the power a millisecond later, when I recover that database, it has to be exactly where it was when we lost power. So that means that every time you commit a transaction in a relational database, that's configured for the proper level of consistency and durability. It's actually going to wait until it can write to the disk. Mm-hmm. So a disk that spins at 7,200 RPM, I may have forgotten the exact math, but that basically means you can literally write to that disk 160 times a second. Okay. Which means if you're only committing one transaction at a time, you can't actually commit more than 160 transactions a second. And I've actually seen benchmarks back when I was in the messaging world. Say, oh, how interesting. They handle exactly 160 transactions a second. I wonder why that is.
Right.
There are ways around that, striping your disk in RAID, using solid state disks, using a SAN that has a disk cache. But, if that's what you're doing, if this is 1,000, banking transactions a second, you probably want that. If this is 1,000 weather data queries a second, or 1,000 Facebook status timeline checks a second, you better not be writing to the disk to do those, at least not synchronously. So that's where the real question for 1,000 transactions a second is 1,000 watts a second. At 1 or 10 we didn't really care so much. At 1,000 we do.
So in this case, while we're still looking at sheer throughput, each API call is not created equal. It really matters. So and I'm inferring from your talk that obviously the more that are reads and the more therefore there can be reads in cache. It's going to make it much easier to handle.
Right.
This level.
That's the difference between 1,000 transactions a second being what you're talking about. That's one box, versus 1,000 transactions a second being, oh my goodness, this is a big challenge for us.
Right.
Totally different worlds we're talking about, right? Statelessness is your friend if you can get away with it. Keeping state in memory is your friend. Persisting as little as possible, or persisting in the background if possible. If you have some big complicated update job that touches 5 databases, maybe you can put that on a queue, because you can scale a message queuing system like RabbitMQ or Cupid, or even, I don't know, MQ series couldn't handle 1,000 transactions a second. Last time I checked, but maybe the IBM people will tell me now that it can.
Okay.
But that's going to handle more throughput than a relational database.
Okay. Excellent.
And we talked about app servers before, so we can skip that.
Yeah.
So more. Can the database handle the load? If it can't, now as you get to 1,000 and scale to 1,000, now is the time to start talking about NoSQL.
Okay.
If you used MongoDB because you love MongoDB early on, that's great. If you used Cassandra because you loved Cassandra, and you think the data model is really great before, that's fine. But if you used MySQL up to this point, I think you're also fine. Once you get around here, though, now you're either going to start deploying exotic relational databases on exotic hardware, you're going to be using sharding, or you need to start looking at Cassandra, Riak, Voldemort, one of these databases that's designed to scale horizontally. So that now, for one, those kind of databases actually handle high write volumes very nicely. Depending on how you use them, they can handle high read volumes, and you can scale them horizontally. And you can make them available across data centers.
Right.
So, my point being that I love NoSQL or using Cassandra all over the place in Apogee. You don't need it for one If you're handling 10 transactions a second, you say, oh, I had to use Cassandra because MySQL doesn't scale. At 10 transactions a second, doesn't matter. At 1,000, it does.
Got it. And so,
in my opinion, and I know there are problem domains where you're going to contradict me every way, but that's my totally general subjective opinion.
And well defended with the asbestos shield.
Right.
So
should I mention Helios while I'm on
No. Stay right off of that. So what you're saying, if I understand, is that you could probably make some industrial strength traditional database systems if you've got things correctly deployed and clustered. You could probably make it work at this level. Going to a horizontally stackable, like NoSQL kind of system might be the easiest path here.
Yes, especially if you don't have a lot of money.
Okay.
A scalable, horizontally scalable Cassandra cluster is not that expensive. Using something like Amazon DynamoDB, it's not that expensive. Scaling Oracle, absolutely Oracle can handle this load. Absolutely DB2 can handle this load, but you're going to start paying some money.
Okay.
Now, it might be better off for you to spend that money than to hire a bunch of Cassandra hackers, but you have a choice.
Okay,
right?
And those are the options.
Yeah.
All right, great. And I love that 160. I'd never encountered that in my career. And now I know that if I ever see suspicious numbers like that, that now I know where to look. All right, well, we don't have a botanical representation of this particular jump here.
We use the redwood. We have to find like the giant sequoia for
I don't know.
one.
So
the general Sherman tree or something.
We've surpassed trees and gone to, because I guess when you're doing 10,000 transactions per second, it doesn't matter anymore. The picture of a tree is just not going to help you.
Right.
10,000 transactions per second is some serious. This has got to be a key part of your business at this point.
Yes, I mean you're talking about 25 billion API calls a month. 864 million API calls a day. So again, 10,000 read-only transactions a second is still one Apache HTTP server or something with a couple of memcached in it. But it's also a gigantic Oracle cluster or a bunch of Cassandra nodes running on good hardware, or a reasonably sized memcache cluster, right? It's a cluster of Java app servers or maybe .NET app servers, or a really big cluster running Ruby on Rails or PHP or something on that, right?
Okay.
You actually are starting to tune your code, because at 1 or 10 transactions a second, you may be a brilliant programmer and you come up with a great non-blocking algorithm for doing something in Java, and you're very proud of your code. It doesn't really matter. At 10,000 transactions a second, it does.
Okay, excellent. So this is where it gets very, very serious, and probably anybody achieving this kind of traffic is going to have some kind of IT behind them, trying to set up these clusters, trying to do this tuning. What you're saying is this is the point where it's not just about which brands, which vendors, which flavors I'm choosing. I really have to take my code pretty seriously here.
Yeah. And the other thing, I got a few, we'll go on. I actually put this. But caching, obviously. No problem for a good caching server if you can cache, right? So it depends totally on the nature of your API. If you're doing 10,000 credit card transactions a second, first of all, congratulations. Second of all, you're probably paying more money to Visa than any of us make in a year. But that's going to be a lot harder to scale than 10,000 queries a second, or 10,000 reads a second. I've said that about 10 times, but it makes such a big difference. Databases, too. No single database server can write 10,000 times a second that I've seen, unless you put it on the biggest hardware, or solid-state disk, right? But a cluster of database servers, or a clusterable database.
Okay.
That cluster, Same with app servers. You're going to have more than one. So now how are you doing session management? How are you doing load balancing? Can your load balancing be stateless, so you can just auto-scale that thing horizontally based on CPU load? If so, great. Otherwise, not. So that's that's something to think about, right?
Okay, and this is where, correct me if I'm wrong here, this is where you might want to start thinking about not manually setting up these clusters yourself, using some kind of fabric, using other technologies that are out there, not trying to solve these problems.
Exactly. So, if you have auto-scaling technology, if you're using Puppet or Chef to deploy, totally a whole lot big difference between, there are 2 servers handling the load and you need to add 2 more, so that engineers have got to log in and configure them manually, versus you can call your ops guy, or you can do it yourself and type a Puppet command or an mcollective command to say, deploy 2 more nodes. Boom, you're done. Great, look at that. Look at the graph, We're working again. This is where you really had to have some monitoring. We talked about testing. Don't forget that you had testing the whole time. This is where if you haven't been monitoring your CPU usage, or monitoring your disk usage, or monitoring the memory growth of your servers, now you might be in trouble, right?
Yeah, this
You're not going to know what the problem is.
Yeah, well, this is where you start to hit that kind of catastrophic success, right? Now your success is actually exposing the things that you didn't take a look at earlier, and now you're going to start to have some angry partners and users probably.
And you probably have high latency. So in your monitoring, you're monitoring the CPU usage of your nodes, but you're also monitoring the network bandwidth, and you're monitoring the latency of your API. Latency is going up. Can we throw more servers at the problem? Or, boy, the API is really slow, but none of my servers are using more than 16% of the CPU or something. Well, is there a locking bottleneck in the code? This is where that starts to make a difference. Did you configure your app server to use all the threads? That'll make a difference. Did you configure your database to use all the memory? Databases like memory, even Cassandra, right? So, did you configure your Java heap not to be bigger than the amount of memory you have on your box, and stuff like that? Things like that start to kill you at this point. This is where it starts to get to be really fun.
Okay.
And lastly, and I'm not going to talk a whole lot, we're going to stop at 100,000 a second. That's 8.6 billion API calls a day.
Per day.
Now you're getting into, Google, Facebook territory. I think that I'm sure that they have more than this, but you're getting there. You're getting into stock exchange trading volume kind of stuff, So basically, it's kind of what we've been saying about 10, only even more so. You know, you're going to have a cluster of database servers. You're going to have a cluster of app servers. You might have multiples in different locations. You're going to have clusters, you know, you're going to have multiple load balancers even. You're going to be monitoring everything. You're going to be scaling horizontally. You're going to be spending a lot of money on infrastructure.
Got it.
You can still do this in EC2.
Yeah.
Companies bigger than us have done this in EC2, but you're going to start looking at network bandwidth.
Right.
You know, you're going to be thinking maybe I should, you know, maybe not build my own data center, but get some rack space somewhere. You know?
Right. Exactly.
That's where, you know, cost really matters. You know, this is where, you know, when Facebook got to this level, this is where they wrote the compiler that compiles PHP into C, because they said, well, if it saves, you know, 20% of the CPU, that doesn't matter back when we had 2 servers, but now that we have 1,000 servers or whatever it is, that's starting to cost us some real money. You know?
Okay, so there's really no, obviously at this level of traffic, there are very few companies doing this kind of API traffic right now.
But it's a growing number.
It's true, as APIs become
You're attending
more,
the Velocity conference, you might be presenting at the Velocity conference.
Right,
you know, so, you know, that's the kind of stuff that comes up.
But the parenthetical there is very interesting to me. Either that or your API is very poorly designed. Did you want to comment on that at all?
Yeah, I mean, and actually, I got this comment from someone from someone who we work with who said, you know, they have X amount of API traffic, and their goal is actually to have less API traffic in the future, even though their business is going to keep growing, because they want to design their API to be more efficient. You may have 100,000 API calls a second that are doing productive work, or you may have 100,000 API calls a second because it takes 10 or 20 API calls just to do the most basic stuff. Keeping in mind that every API call, and we got a slide later, but we're running out of time here. Actually, we can actually step forward 2 slides and talk about exactly this.
Okay.
So why don't we do that? Other considerations. Every API call, it's got a TCP connection, SSL, handshake if the connection didn't stay open. It goes through the load balancer. If you have an API proxy, it went through there. It goes to an app server. It gets dispatched to a thread. It uses a database connection. The database may or may not read and write to the disk. That's a big, big stack. Every single one of those you make, maybe some of them get, you know, handled by an API proxy and returned out of cache. Maybe some don't go all the way back to the disk, but a lot of them do. So maybe you don't need all those API calls. Maybe your API is designed in a way that, you know, maybe you followed all the principles of the whatever REST maturity model that you read about, and it takes 10 API calls just to get a cup of coffee. You know, maybe you want to have just one API call that says, get me a cup of coffee and here's my credit card number. So at this level of traffic, your API design is going to cost you money. So for instance, and it's going to add latency. 10 or 20 API calls made in serial takes 10 or 20 more times than one API call. So maybe you can design your API so that the users can send a smaller number of high-value API calls, and then maybe you have a proxy layer or an app server or an orchestration layer that then fans out to all your back-end systems and does the heavy lifting.
Got it.
That's where this stuff starts to make a difference.
And that's interesting because we have been focused sheerly on throughput this entire webinar, and in fact, while it is a good metric, it is a good scorecard, I think the point here is that it shouldn't be our only scorecard, because if it's poorly designed, we may be just, what you're saying, we may be thrashing a little bit. We may be overly chatty. We may be patting ourselves on the back saying, hey, look at all this traffic we've got.
Right.
But it doesn't represent unique users or value-added traffic.
Right. And I think there's an analytics aspect here. I mean, in the world of web analytics, in the early days, everyone talked about hits. And pretty soon they figured out that, you know, hits to, you know, download the images for the cute little icons don't really drive any business. What I really care about is engagement and number of unique visitors. Right. Same with an API. Right.
Okay.
Sheer number of API calls is not anything. So that's just, you know, something to think about.
Okay. I think it's an excellent point.
Talking about clients. Can you prevent the clients from making the same API calls over and over? We've done some mobile app optimization talks in the past, talking about the value of compression. HTTP has, and here's where I will make a REST plug, HTTP has got some very nice features in it for conditional requests. You can say, get this only if it's different from the last time I got it, or update this only if no one else has updated it. An API proxy layer or an intelligent app server can intercept that request, not return any data to the client other than a status code. Saves you a trip to the database, saves you network bandwidth, can you use that? Can you put in things like pagination and partial response kind of features to your API so that a client can request only the data it needs?
Okay.
We've talked about this in previous webinars,
Yeah.
but these all make a big difference.
Well, it ties in beautifully with the chattiness topic that we were just talking about. That
Yeah.
if you tune the client a little bit, you might be able to, ironically, at the high end of traffic, reduce your traffic a little bit and
Yeah.
make it more value add.
Latency. We talked only about throughput, but latency obviously is tremendously important to your user experience. All this throughput talk I'm having about 10,000 and 100,000 API calls a second, just to reiterate, we're assuming that that only means something if the latency is reasonable. So what are things that kill latency? For mobile devices, large responses and requests kill latency. Requests and responses that are complicated and expensive to parse hurt latency because mobile devices have slow CPUs, although they're getting better. Distance kills latency. If your APIs are all in the west coast of the US and your customers are all in India, they're going to be spending on 200, 300 milliseconds just getting to your API. So
Right.
can you host your API closer to your users, or can you cache API content closer to users?
Okay.
So that's where the ability to have caching proxies all around the world can be really valuable. Depending on the nature of your API, you might be able to take advantage of a CDN. So for instance, if it's a big thing you're asking for, get a video, get an image, get a file, can the API either redirect the user or return a link to an actual CDN so that they'll get a cached copy that's in their neighborhood?
Okay, that makes sense, and that is kind of a different thing. So we talked about the sheer throughput. We've talked about tuning on the client side, and this is just a quick dip into the idea of latency. But I love the idea of horizontally scaling via geolocating near where your user bases are as a quick fix to some latency issues. So
Yeah.
make them happier, and then if you have horizontally scaled, obviously you can process that much more traffic too.
Yeah.
Okay.
And the last thing, I probably should have put this back at the 10,000 request a second page, but maybe next time we do this. But there comes a point at which you got to think not just about your infrastructure, but also your network bandwidth. For instance, EC2, which I have a lot of experience with, has a very, very big connection to the internet. Each individual node, however, only gets a gigabit per second. So if you're talking about 100 API calls a second, you're not even going to think about it. Once you get into the 10,000 range, you might want to break out the calculator and do the math before you hit yourself over the head trying to figure out why something isn't scaling, because it may be that you've saturated the network. And a lot of people forget to check that sort of thing. Certainly if you're hosting it yourself and you don't have a gigabit connection to the public internet, that's definitely going to fall apart before then. So,
Right.
for instance, a gigabit per second at 10,000 API calls a second means you get about 12K. If your API calls are 50K, you're not going to get 10,000 API calls a second unless you have more than a gigabit connection to
Interesting.
the world.
So this is the first time the message size has really crept in.
So
here.
the size of the message has an actual, forgetting about just getting to the mobile devices, which are a lot less than a gigabit per second, but just getting from your API out to the internet, you will reach a point at these high scalability levels where you've actually got to think about what kind of interconnects do I have? Do I need to have 10 gigabit interconnect? Maybe if one 5K API call results in 20K of traffic on the internal network because I'm touching a lot of different databases or doing complicated queries, you might have to do the math and say, well, the API can handle it, but internally on my network, we're all the way up there. Good network ops people will check this, but not everybody remembers to look. And I've seen a lot of cases where we pounded our head against the wall and someone broke out a calculator and said, we're talking about almost a gigabit per second here. That's actually a lot of bandwidth.
Right. No, I love this point. I think this could be so easily overlooked.
It absolutely is.
And you think you're handling traffic. You think it's all about the perimeter or about your database.
Yeah.
I love the idea that it's actually what is it kicking off around your internal network, and what is that total aggregate traffic, and can your network actually handle that?
Right. I mean, in a corporate setting, you may not even have a gigabit network, or you may have some database that's on a very highly saturated link on another segment. If you've got your own data center, this is absolutely something that you're thinking about.
Excellent. I love that point. That's terrific. All right, I think
that's the end.
Yeah, that brings us to the end of what we had prepared. As always, you can get a hold of us on the API Craft Google group or on the IRC channel, and also you can leave comments on our YouTube channel, and we'd be happy to continue the discussion with you guys on those various media. Otherwise, thanks everybody for joining us today. I'm so glad you took the time to spend another hour with us on one of these webinars. We hope it was useful to you. And we apologize for any of the technical difficulties today. We'll get that all sorted out for next time.
And it sounds like you're hanging up. So
all right.
I guess it was good. Thank you very much. See ya.
Thanks, everyone.